random variable. Random variable is a function which maps from domain sample space to a codomain real set. So a random variable is usually denoted by a capital letter. It's a rule from a sample space to real number set. What is this sample space? Sample space is a set of all possible outcomes. Set of all possible outcomes. Suppose, for example, if we toss a coin, the set of all possible outcomes we can write as head or tail. So this is a sample space of an experiment tossing a coin. Similarly, if suppose we take rolling a die is an experiment, then a sample space of an experiment is the set of all possible outcomes are 1, 2, 3, 4, 5, 6. As the die consists of 6 faces, any one may be the outcome of an experiment of rolling a die. So the sample space possesses 1, 2, 3, 4, 5 and 6, etc. So in this way we define a sample space is a set of all possible outcomes of an experiment, and if we take a sample space as a domain and a real number set as a codomain, and the function which maps from S to R, that is called a random variable, and it possesses all the events of the experiment. And every event, what is the job of random variable means it assign a certain numerical value to every event of a sample space. So here by assigning a certain numerical value we can be able to take a decision which helps in making the decision making. So a random variable is a very important tool in decision making, and usually the random variables are of two types. Basically we can write so one is discrete random variable and the second one is continuous random variable. So the two types of random variables are we are going to discuss now. So the first one is a discrete random variable. So what is this a discrete random variable? So discrete random variable is that random variable which simply we can define as the discreteness means simply we can say which is not continuous, that is which is distinct in nature, that is a different, possessing a different values. So for example we can understand very easily, suppose x assigned with a values like 1, 2, 3, etc. So every value which is assigned to x is a discrete in nature. So this represents the discreteness. That means we can simply define as an infinitely a finitely an infinite countable set. An infinite countable set is a discrete set. So which is for example here if we move on path from one source to destination, that path must be obviously continuous. So from source to destination the path must be continuous, but the speed where we move from source to the destination, it varies from time to time. That represents the discreteness. So here we define the discrete random variable in such a way that the values which are assigned to the x which are discrete in nature. And similarly the continuous random variable, here suppose if x is taken with values provided between 1 and 2, suppose this is an interval, a closed interval, so that x takes all the values from the 1 up to 2. That means there are an infinitely many real values between 1 and 2, and each and every value will be taken by x starting from 1 up to 2. So that represents the continuous. So this kind of random variable we usually call it as a continuous random variables. So let us take a simple examples of these two kinds of random variables. Basically, suppose here we take our usual experiment called tossing a coin. Then if a coin is tossed for or flipped for 3 times, then we can assign, suppose let me write x is taken as the getting number of heads, getting number of heads in tossing the coin. Then what are the possible values I can assign for getting the head? So that can be given by, in tossing the coin that and flipping that coin for 3 times, then I can get the possible outcomes or set of all possible outcomes. S can be taken as, so all the 3 may be heads, this is the one outcome you can expect, and 2 heads 1 tail, 1 head, tail and head, and the first head and the remaining 2 are tails, and tail 2 tails and 1 head, and 1 head and 2 tails, and tail, head and tail, and finally all the tails. So these are all the possible outcomes of that experiment, that is flipping the coin for 3 times. So 3 times you may get the head, or 2 times head 1 tail, and similarly 1 head 1 tail 1 head, and 1 tail 2 times may be head, 2 times tail and 1 time head, and first time may be head and then the remaining 2 tails. And in this way we can have the possible outcomes of the flipping a coin for 3 times. Then I can assign the values for this random variable x in such a way which representing the discreteness, as here we can expect this getting a head, if I considered as a random variable x, then we can have that x may be 0. That means there is a no head, and this is the case where there is a no head. So x may consider the value 0, and x may be 1. That is x, it is where we have only 1 head. In different cases you can take, this is a 1, this is a 2, this is 3. There are certain cases where we have only 1 time head, and there are certain cases we have only 2 times head, and similarly we have certain cases all the 3 are heads. So these are the different values we can assign for the random variable x, and so this represents the discreteness of the x. And here we can build a probability distribution table for this experiment by considering the values and the corresponding probabilities of that x. And this may be, if suppose we have given the values for the random variable x as a 0 1 2 3, suppose, then what the probabilities to the corresponding values of the x considered. Suppose x is taken as a 0, that represents there is a no head, as we defined x is a getting the head. So that represents if there is a no head, I have only one case out of 8 cases, so the probability is 1 by 8. And if suppose we are taking that getting a head, that x is taking only one, and there are the certain cases in this experiment 1, 2, 3. So there are 3 possible cases out of 8 possible total cases, so 3 by 8 is the probability. And getting 2 heads, similarly 1, 2, 3, so 3 by 8, that is a probability. And finally getting all the 3 heads is only one possible case out of 8 heads, and this table we call it as a probability distribution table of the experiment of flipping a coin for 3 times.